let's do a summary of the things that they want us to know. So the six common integrals. So it's going to be, first of all, let's do it. The integral of e to the ax plus b, okay? So you have to say with respect to x, okay? You have to say with respect to x because it is always integral with respect to something. Now, we now know the trick. The trick for integrals is if you're integrating a composite function, integrate the function and then divide by the derivative of the inside. So integrate the outside, then divide by the derivative of the inside. So I integrate e to the something, it just comes back as e to the something. So this is going to be e to the ax plus b. Then I divide by the derivative of the inside, which is the derivative of ax plus b. This is 1 over a, okay? It's like you divide by the derivative of ax plus b, which is a. And to divide is like to multiply by 1 over a. So that is why we multiply by 1 over a. It's like we have divided by the derivative of ax plus b, okay? Then you put your constant of integration c, and you're done with the first one. So this is going to be the first one. This is all you have to do. And that's the same trick we're going to be using for all of them, honestly. So let's do the second one. It's going to be the integral of 1 over ax plus b, okay? And this is with respect to x. This is with respect to x. What am I going to get here? Well, 1 over something, it is ln, buddy. So this is going to be 1 over ax plus b. It is ln of ax plus b, okay? But since this is not an ln x, remember you need to put modulus because ln is only for positive things. Now remember that since this is not 1 over x, it can't be just ln x. This is a composite thing. What did we say? Why do we say that? Because, okay, this is something which is just more than an x, right? So when we integrate it, we should then multiply by the derivative of the other guy. So we then multiply by the derivative of ax plus b, which is, we then divide, by the derivative of ax plus b. We always divide. Integration, you always divide by the derivative. So derivative of ax plus b, which is a, so you divide by that, which is like to multiply by 1 over a. So it is 1 over a ln ax plus b, then you put your constant of integration c. So it is 1 over a. Then ln, so this is ln ax plus b, then you put your constant of integration c. Very easy, I know. Then now we go to the next one. What is number 3? The integral of sine ax plus b with respect to x. Well, remember that for this, you need to remember your common derivatives table. Who gives me sine? I know that if I differentiate cos, I get negative sine. So if I integrate negative sine, I get positive cos. It's like you're going back. I get it. Because if you say d dx, derivative of cos x, right? You get negative sine x, okay? So now you're integrating. In other words, you're going back. So if I integrate negative sine x, I go back to cos x. But now I'm integrating positive sine x, so it will now give me negative cos x, okay? If it's now positive sine x, it will go back to negative cos x. So that's how to, remember, try to think of where it comes from. So here's the thing. We can just say this in simple terms. When you are differentiating, if you differentiate sine, you get positive. Let me put the things. This is y and dy dx, okay? So here we can have sine x and we can have cos x. If I differentiate sine x, I get positive cos x. If I differentiate cos x, I get negative sine x. So in other words, in differentiating, sine is the one that stays positive. But the opposite is true in integrating. So in differentiating, I know that if I differentiate cos, I get negative. So when you differentiate cos, the sign always changes. Whenever you differentiate a cos, the sign always changes. When you differentiate sine, the sign stays the same. Now, when you integrate, it's opposite. If you integrate a sign, then the sign changes, okay? So here we are integrating a sign, so the sign will change. So it will give us negative cos of ax plus b. Then remember to divide by the derivative of the inside. And that is, the derivative of inside is a. We divide by a, so it will be negative 1 over a. It's like dividing by a. That is what you do, and you'd be done. So this is what you simply have. Then we go to 4. We integrate cos. Okay, remember to differentiate cos, we know the derivative of cos, and we know it changes to negative sign. But to integrate, it stays the same, so it stays as a sign. So this is going to be, it's sine of ax plus b. The inside does not change, the inside doesn't change. But then you divide by the derivative, so it'll be 1 over a. But remember to put your constant of integration, oh my. Remember to put your constant of integration c, okay? I know you can do this. I know you can do this. This is your plus c. Now we've got two more. Come on, come on. We've got two more. Let's put it. Now this is going to be, number 5 is going to be the integral of sec squared ax plus b. With respect to x, of course, with respect to x. What am I going to get? The integral of sec squared ax plus b. Remember where sec came from? It came from tan, right? So sec squared ax, if we start with the outside, just the sec squared, it becomes tan. Of what? Of ax plus b. Remember the inside doesn't change. Then you divide by the derivative of the inside, which is a. So it will be 1 over a. Okay? Then you should put your c. Okay, you just divide by the derivative of the inside. Remember that. I know you can do this. I'm counting on you. Come on. One more, the sixth one. This is going to be the integral of 1 over x squared plus a squared. And we're integrating with respect to x. What am I going to get now? Well, 1 over x squared plus x squared, 1 over x squared plus a squared, you're integrating with respect to x. Where did it come from? It came from tan inverse. That is where it came from. Okay, you ask yourself, where did it come from? It came from tan inverse. So now, what am I going to do now? Well, you're going to say, remember that this, we said, this is the only one which I would need you to remember. It was just 1 over a tan inverse of x over a, okay? That's the one which you're going to need to remember. Tan inverse of x over a. Then you do plus your constant of integration c. So this is going to be what you must remember. And you are done! And you have killed it! And I'm proud of you! Okay, that is it. We can do this. We now need to go to questions and we need to box them. Goodbye for now. See you in the next one.